Take it away.
Hey everyone. So as Matt mentioned, I'm going to talk about simplifying microservices. Just a little bit about me. Spent most of my career building platforms in various forms. Started out as a sysadmin, then an SRE at Google, and most recently a software engineer at Halo. That's where most of my microservices experience comes from. Getting right into it, what is micro? Well, it's sort of a lot of things. I think, like a lot of people, I suck at naming. Naming is kind of hard. But today, I just want to talk to you about the toolkit. So micro, essentially a microservices toolkit. It's what I think of as the building blocks for microservices, and the goal was really to create something that would simplify building distributed systems, and also be pluggable in a way that as technology advanced, you would be able to switch out the back-end systems that you were using. But before we kind of get into the details of micro, I just want to rehash this thing, called microservices. So I'll throw out a quote there from Adrian Cockcroft, loosely coupled service-oriented architecture with a bounded context. Pretty good. I thought I'd take a crack at it as well. So my thought is really turning a big ball of cruft into smaller balls of cruft, which communicate over a network. Maybe not quite as eloquent as Adrian, but I think it makes a point of, essentially what we have is potentially this monolithic application, and we're breaking it down into smaller applications that communicate over a network, right? And you might think, well, why are we doing this? And this is kind of my non-exhaustive list. I'm being a little bit facetious here, but the idea is that at a certain point in the lifetime of a company, it reaches the breaking point in terms of scale, both organizationally and technically. And the natural kind of occurrence of that is to break down those systems. And a lot of the time it's there's millions of lines of code, there's hundreds if not thousands of people. It becomes very difficult for all of those people to work on these things at the same time. And so naturally you move towards breaking it apart and splitting up kind of control, and essentially I see it as a way of making it easier to build, manage, and scale systems independently. But clearly we all know this. I think we've kind of been hammering this home that there are trade-offs. It's not really the first step you would make in terms of designing software, right? There's operational overhead when you get into building distributed systems. Rather than having a few moving parts, you have many moving parts, and a lot of the times it requires a different kind of skill set to build those systems. And I think one of the things that we have to realize is this whole microservices stuff, it's not really the answer to everything. You have to be pragmatic when you're kind of building systems, right? It's essentially an architecture pattern, and there are many patterns out there which you could use. But moving away from that, talking about why I did this, why I built this toolkit. Well, I think building distributed systems is still hard. I think even for me personally, I just see it as there are still, while technology is advancing, there's still a lot of those same problems, right? So this is straight off of the Wikipedia, the distributed systems fallacies. And the whole idea is that, the network is not reliable, and that thing that was a function call is now essentially a function in a process on the other side of a network, and any number of things can go wrong there. And that's just one aspect of it. There are many different problems that occur there. So it's still kind of this problem. And I think while we've got these newfangled systems like AWS and Google Cloud and things like that, and we have this cool stuff coming about like containers and all these different tools that kind of help us to run distributed systems. I think there's still this question of how do I actually write distributed systems? I think there's still some difficulties there, and that's where that kind of is what led me into the origin of micro, essentially, where back in 2014 I was working at Halo, and we had built this microservices platform, and it was this really awesome thing. I felt like developers are very productive. There was all this kind of tooling, but there was no real we weren't really planning to open source it, and I wanted to use some of these kinds of tools and concepts outside of Halo. And I saw, all my friends leaving and essentially building the same things because they wanted those tools as well. And so I thought, wouldn't it be, interesting if I tried to build something open source? And so in January 2015, I open sourced this pluggable RPC framework called Go Micro. It was essentially what I thought were the building blocks or the things, the problems I needed to have solved at the core so that I could write distributed system software. And at the time, YouTube had forked NetRPC into a library called RPC Plus, and that provided a way to pass context as the first argument to handlers. And I found that useful, so I decided to kind of build around that. And then eventually, it ended up evolving into something of a toolkit. So once I had this framework that allowed me to write software, I found that now I had to actually, I had to query this in various ways. I needed access via HTTP, and I needed it from a terminal and all sorts of stuff. So it became essentially this thing I'm calling the toolkit. And now today, there are multiple companies using it in production. It was kind of a lucky thing that people came across it, and I was fortunate enough to have the project sponsored by Sixt, the German car rental company, which means I can work on this full time now. And Sixt are actually looking for engineers if anyone wants to, go to Munich and work on some interesting stuff there. But before I get into the details of the toolkit, I want to kind of talk a little bit about the Go landscape, then and now. So 2014. We had the standard libraries, we had Gorilla, RPC, Kite, and then I guess you'd end up building some sort of custom framework around that. And so there wasn't really much out there, and I think you just ended up building something for yourself. And the standard libraries were really good, but you sort of needed these extra pieces, and you'd end up building it yourself. And today, while those solutions are still valid, we're seeing the emergence of these essentially toolkits, right, or software that helps you write distributed systems. So Gizmo from New York Times, GoKit from Pierre Bourgain, gRPC from Google, and a number of other solutions as well. And I think it highlights the fact that now there is choice, and you can kind of choose to use these pieces of software, or you can kind of continue to build your own. And beyond Go, I think Netflix, you would consider them somewhat the pioneers of microservices in some way. They built, Netflix OSS, which is a pretty mature Java stack, and Pivotal Spring Cloud is based on that as well. And there's a number of other solutions in other languages. And then you're also seeing the emergence of like RPC proxies from people like Buoyant. So Linkerd is one of those things, and I think we'll kind of trend towards that a little bit more as well as we go along, because it means rather than having to, develop libraries in every single language, you can just develop in any language you want and then use this RPC proxy, which handles all of the kind of distributed systems aspects for you. So finally getting into the toolkit. So the toolkit is essentially, again, what I call these building blocks. At the core, there's this RPC framework, which lets you write microservices, and then there's a number of components which essentially help you query them in various different forms, and I'll kind of go into that a little bit later, but I want to start with Go Micro itself. So I keep talking about this thing, Pluggable. I keep saying Pluggable. Essentially, when I started building this at Halo, I think one of the problems we had with trying to open source our solution was we'd hard-coded a lot of things, and it would be kind of impossible to rip that all out and make it work. And I realized when I started this, I wanted to start in a way that this system could be leveraged by many, many different people, many companies, and in a way that you could swap out solutions so you wouldn't be tied to any specific technology. So essentially, each package starts with an interface, and that interface can then be implemented. So say, for instance, for service discovery, you have this interface that lets you query things, and you can implement that, via console, etcd, something else. It doesn't really matter. And I think that was really the kind of powerful thing about this. And it also kind of comes with these same defaults, so it works out of the box really, really easily. And this is kind of the feature set. This is, there's nothing really more to it It's very, very simple and straightforward from my standpoint. It addresses what I believe is the core requirements of microservices. So service discovery, message encoding, request response, and pub/sub, because I think microservices are essentially an event-driven architecture. And what you can see from this image essentially is that it's a layered architecture. So each package at the very bottom, focuses on a specific feature, and then you can essentially pull together these packages and these features to create a client and a server, and then you use that client and server to essentially define a service. And that's essentially how I think about composing software. So kind of getting a little bit deeper in this pluggable aspect. Go has this really powerful concept of interfaces. I think you're all aware of it by now. You all probably know how it works, and you've used it, and you understand it really well. And for me, it was this really interesting thing. I ripped this definition out of effective Go. If something can do this, then it can be used here. So essentially, you define some interface, and then you can implement it. And one example of that would essentially be service discovery. So this is the registry interface for service discovery in Go Micro. And it's essentially, it's a very, very simple abstraction for service discovery. It doesn't include all of the features of any kind of service discovery system, but it includes enough to kind of get you started. And what we can essentially do is, we can implement this interface. So here's some kind of standard, concrete code for a console registry. And then wherever we're expecting the registry, we can, just kind of pass around these things, and it doesn't care. It just expects a registry interface. Although one of the things I just recently learned is, this is not the recommended way to initialize a function. So apparently, rather than returning an interface, I should be returning a struct. So I think I'm going to have to start changing some of my code, but you kind of get the point. And then another example would be the transport for request response. This interface basically provides a way to do bidirectional streaming, and it has socket-like semantics. So it essentially, the socket has send and receive, and you can send both ways. And it looks a little bit like something of the net package if you've looked at that. And then another thing we could essentially do with one of these interfaces is we could essentially mock it. And maybe at build time, maybe at when we're running stuff on Jenkins, unit testing, whatever, we can swap out all of the underlying implementations with mocks and then just test these. And it's a fairly standard thing where you don't really have to change very much of your code to make that happen. It's just the kind of initialization functions that you have to deal with. So it's interfaces are a pretty powerful thing and at the core of this toolkit. So I just want to quickly go over writing a service with you guys. It's about 4 slides. There's not very much there, but it'll kind of give you an idea of what's going on here. So this is essentially a protobuf definition for a service. Working at Google and Halo, I find protobuf to be fairly clear and simple and easy to use. And so, as you can see here, you have the service greeter. It has a method hello. It takes a request and returns a response. And what we can essentially do is we can use the Golang protobuf library to compile this into concrete Go types. And the Golang protobuf library also actually provides a gRPC plugin, which is pretty interesting for kind of stub code for clients and servers. And so I thought that was neat. I'll kind of copy that, and I made something for Micro, which would give me the same kind of features. And you'll see that in a couple of slides. So we kind of compile this down, and then we can import this, and we can define our handler, and you can see this handler, the greeter struct, and it has a method hello. And the first argument is context, so we can do some interesting things with like cancellation and deadlines and whatnot. And then it essentially takes a request, and that's the concrete kind of request struct and a response. You'll see it's fairly similar to the net RPC signature, and then it also returns an error. And then when you're creating a service, you essentially, very, very simple. You create this new service, You can give it a name, you can give it a version. That essentially takes a variadic list of arguments, so you can also pass in metadata and whatnot. Also, it can initialize flags if you want to. Then you can use service.init to actually parse those flags. I know some people don't like flag parsing in libraries, so that's an optional thing that you can do. You don't have to use that. And then here what you see is this kind of, that protobuf generated code. Register greeter handler is essentially some stub code to simplify registering the handler and doing some kind of setup there. And then all we essentially have to do is call service.run. And that's about it. And on the client side, if you're writing a service and you want to talk to this greeter thing, you can essentially use some of that protobuf kind of stub code again to create this client. You give it the name of the service that you want to talk to, and then essentially your client that is fully initialized with your codecs and your transport and everything else. And then you execute the method hello, give it a request. And that's about it. And that's about as simple as it is. And that was really my goal when I was developing this. I didn't want to have to deal with all of the kind of distributed systems aspects of building these things. And at the same time, I wanted to write microservices. But what's it actually doing beneath the covers? So when you call service.run, it's taking that information that you gave it, the name, the version, the metadata, the handler that you registered. It's extracting out all of that information, creating a service definition, and it's using the registry to essentially register with service discovery. It's using the transport to listen and accept requests. It's then using the codec to kind of decode that request, and then it hands off to your handler to actually execute it. And you can also optionally heartbeat with discovery as well. So I think one of the things is, distributed systems. Things are going to fail. Things are going to go away. So if your service panics for some reason and doesn't deregister cleanly, you kind of want that to go away from your discovery system after a certain while. So you can TTL the registration, and then it will register in an interval. And if it hasn't registered in a while, that will kind of just expire from discovery, which is pretty useful. And then on the client side, actually, this is where a lot more of the kind of work occurs. So it's using the codec to encode your request. It's using the registry to look up your service. And then it's using the selector to essentially decide which node to send your request to. There's some optional kind of connection pooling in there. There's retries, timeouts, et cetera, et cetera. But that's where the kind of the bulk of the work occurs. But essentially, when you're writing your code, all you're doing is you're executing functions, and all of this is happening in the background for you. But what about this other kind of stuff, right? So we're talking about distributed systems. There's a lot of other things that we want to deal with: rate limiting, circuit breaking, authentication, distributed tracing, et cetera, et cetera. I knew it was important, but at the same time, I didn't want it at the core of the code. I wanted to create something that would provide a way to, extend that. And I think that's where the idea of middleware comes in, and what I'm calling wrappers, essentially, because what it's using is the decorator pattern. And so it's essentially augmenting the behavior. The wrappers will essentially augment the behavior of your handler or your client, and the actual core code will not really know what's going on, but you can add things like authentication and distributed tracing and things like that to it. And so the idea is essentially it's like the layers of an onion, right? So you've got your client, you've got your handler, and you can just wrap around that and kind of do all of these things if you'd like to. And what that definition looks like: a wrapper is a function that takes a client, returns a client. Handler wrapper is a handler function, a function that takes a handler func, returns a handler func. And then when you create your new service, you can essentially pass these things in and initialize that at that point. And an example of a really, really horrible rate limiter, which I don't advise you to use, and actually I haven't even used. I just kind of wrote this code, and I'm not even sure if it compiles. But the idea is, here's a function that returns a handler wrapper. It does some setup, so it creates some tokens, and then it essentially returns the signature of the handler wrapper, which will, try to retrieve a token, execute the handler, and then defer, putting back the token. So that's sort of a simple example of how that works. So that's it. You can now start writing services. But I think once you get to that point and you write some services and you put it somewhere, the next question you have is, how do I actually access these things externally? That becomes sort of a question. And because this stuff is RPC, the last thing you want to do is be sending around like serialized protobuf everywhere by hand. And so that's where I've got these things called entry points. And that starts off with this thing called the micro API. So it's essentially an API gateway, simple API gateway that uses path-based resolution to determine which service to send a request to. And it will receive HTTP, and it can either convert that to an RPC request and forward that on, or you can run it as a reverse proxy if you're interested in building kind of REST-based solutions or something. And what I'm essentially doing with that is I'm creating this logical partitioning of services. So there's this, with the micro API, we define an API layer of services. And the idea is, there's this separation of concerns in terms of what these services should do. So, you have this customer API. It might actually talk to a number of services in the back end, then transform that into some request that you want to hand off via the API. It could be that you don't actually want to expose all your back-end services through your API, right? There's also a web dashboard, and for me, it was just, I needed a way to kind of visualize what's going on, simple way to look at stuff. But also, it comes with a built-in reverse proxy, and the idea was, when we were at Halo, we were building web apps as microservices, and I find that to be a really powerful concept. And I thought, I want to kind of continue on with that as well. So it allows you to do that. And it uses the same kind of path-based resolution as the API to let you break down, your domain into many web apps. And then, if you're kind of composing this as a whole, what you're seeing is the tooling is kind of guiding the architecture patterns, right? It's saying, here's the logical separation of responsibilities in terms of what your application should do. It's a very opinionated way to build things, but I think based on my experience, it was something that worked really well for us at Halo, and I kind of like the way that works because I don't really have to think about this as I'm building all of these systems, right? It's there. The architecture has kind of laid out this pattern. It's almost like painting by numbers or something like that. Another thing that's in the toolkit is something I call a sidecar. It's kind of like a proxy. So the idea is that it replicates all the features of Go Micro as a HTTP interface. So if you're developing things in different languages, you can use this HTTP interface to access those. It also acts as a proxy for the CLI. So if you've got some remote environment that you want to talk to, I think what we all end up doing is setting up some form of VPN or SSH or something, to kind of get into the systems. And this is another way to kind of do that. Standard CLI built into it. As you can see here, there's kind of the extracted endpoint information that you can then query. You can query services from here. I just found, this is kind of a natural and logical way to query services, to find out about your environment and what's going on. And then finally, there's a bot, and please don't heckle me for the fact that there's a bot. This is kind of the notion of chat ops, right? So the idea of Hubot. I think what we found over the past few years is that messaging has become a de facto entry point, much like an API. So HipChat and Slack is where you do some of your work as well. And I thought, it's something very, very simple, but I wanted to kind of build it into the toolkit because I felt like it was necessary. I might have been sleep deprived at the time as well, but and then beyond the toolkit, there's just a few last things that I want to cover. So, I talked about this pluggable aspect, and I knew that when people are going to adopt software, especially open source software, they want these things to already be there. So I created this repo, Go Plugins, which has a number of plugins. So if you want to use etcd or Zookeeper instead of console, you can. If you want to use Kafka as a message broker, you can, and there's much other plugins there as well, and actually there have been some kind of contributions from the community, which is really great. So I hope if people want to contribute, they will. I'm also working on something I call the Go platform. So, I talked about the building blocks that the toolkit give you, but I think when you're building software for production, when you're building stuff at scale, there's all these higher level requirements that you have to address. Authentication is probably the first one that you think of. But also, when you have 50, 60, 100, 500 services, it's very difficult to make sense of this, so distributed tracing and whatnot. And it follows on the same pattern as the toolkit, where it's just interfaces that can be implemented, and then they can be used with the toolkit itself. There's also a Slack community, which is growing pretty quickly. It's around about 500 members now, and people might ask, why don't I have a channel in the Gopher Slack? It was just one day a friend said, hey, we're chatting on Google Hangouts. Hey, we need somewhere to talk about this stuff that you're building. So we just create a Slack, and then it kind of took off from there. And I think the idea is that Micro will probably go beyond just Go at some point, and I wanted a place for that. And also, companies will come in and maintain kind of private channels to talk to me about the toolkit, which is pretty cool. And that's about it. But I just want to close with, this is a toolkit to help simplify microservices. This is my piece of work. It's an opinionated system, and the people who use it, they love it very much, and I think it's not going to be everyone's cup of tea. And I think the great thing is that we have the freedom of choice, and there's a lot of tools out there, and I think you should pick the tools and patterns that work for you. And microservices is not the be-all and end-all of everything, but I think it's pretty useful in a certain context. And that's it. So thanks very much for your time.